Good morning, students. Today we will start with electron displacements. Electron displacements means where displacement of electrons takes place, that is movement of electron takes place. In this category we have mainly four effects: inductive effect, resonance effect, hyperconjugation, electromagnetic effect. There are four types of effects under electron displacements. First we will start with inductive effect. What is inductive effect? As we have already done in lower classes also, it is the process of displacement of electrons, especially sigma electrons, along saturated carbon chain due to the presence of polar covalent bond at the end of carbon, and it is denoted as I effect. So inductive effect is, it is present in the chain of carbon and it is due to the presence of some polar covalent bond present at the end of the carbon chain, and it is designated as I effect. So we can show it as C single bond Cl. This bond is polar covalent bond, therefore the electrons move slightly towards this carbon, and these are shown with arrows indicating the displacement of these bonds towards this carbon, and it is due to this halogen attached at the end of the carbon chain. So it is a inductive effect, and it is of two types. First is minus I effect, second is plus I effect. So let us start with minus I effect. Minus I effect is, that is, the atom or group attached at the end of the carbon chain as electron withdrawing, that is, it withdraws the electrons from the chain or it withdraws the electrons away from the chain, then it is said to have minus I effect. So in this, the order of different groups are: NO2 is strongest group, then CN cyanide group, then COOH carboxylic group, fluoro, chloro, bromo, iodo, then OH, then OCH3, that is ether group, then benzene, then hydrogen. So it is the order in which they withdraw the electrons from the carbon chain. In this case, NO2 group is the strongest and hydrogen is the weakest group. So similarly, in plus I effect, we have atoms or group of atoms having strong electron donating power, or they are releasing groups. They releases the electrons towards the carbon chain. That is, these groups are generally alkyl groups. So it can be tertiary group in which this carbon has CH3 attached to it, or it can be secondary group in which carbon has two alkyl groups, and it may be primary in which one alkyl group is attached, or it can be simple CH3 group. So these groups have electron releasing tendency towards the carbon chain. So secondary 3 degree, then 2 degree, then 1 degree, then simple methyl have positive I effect. And next is electromagnetic effect. In electromagnetic effect is a process in which it involves the movement of pi electrons. Earlier we have done inductive effect. In inductive effect, only sigma electrons move. Sigma electrons move means it involves single bond, but in electromagnetic effect it involves the movement of pi electrons, and it will be only in multiple bond. In multiple bond, the movement of electrons is called electromagnetic effect, and it is denoted by E, or say it is designated as E effect. Then it is further of two types, that is plus E effect and minus E effect. Plus E effect means when electrons of pi bond move to atom to which attacking reagent gets attached, that is this attacking reagent, if it gets attached to this multiple bond means double or triple bond. So when it is attached to this, when electrons move to this electron will carry negative charge and it is positive charge, so it will get attached to negatively charged carbon, so it will attach to this carbon, that is this carbon, and the other carbon, this carbon will have positive charge. So when the attacking reagent is attached to the carbon to where the electrons are moved, or say the pi electrons moves towards the carbon where the attacking reagent gets attached, then it is said to have plus E effect, plus electromagnetic effect. If the electron's movement is to the other direction and atom gets attached to other atom, then it is minus E effect. That is, we can see in this C double bond O. In this, if Cn negative attack cyanide ion attacks, then these electrons moves towards carbon as oxygen is more electronegative, then this will attach to carbon with positive charge, this will carry positive charge, so this will attack this carbon. So pi electrons moved towards right direction, but cyanide gets attached to left side carbon, so these are opposite to each other, so it is minus I effect. So electromagnetic effect is the movement of pi electrons. If the attacking reagent gets attached to that carbon atom towards which pi electrons were moved, then it is plus E effect. If attacking reagent attacks to other carbon atom and electrons moves to opposite direction, then it is minus E effect. So we have shown this with examples. So next is hyperconjugation. So hyperconjugation is very important topic. In hyperconjugation, we see that it is the interaction between the electrons of pi system and the adjacent sigma bonds of substituent group are called hyperconjugation, and it is also called Baker-Nathan effect, or it is also called no bond resonance. So in this, the electrons of sigma bond gets involved with or gets overlapped with pi orbital or with p orbital, then it is called hyperconjugation. So it is an interaction. So it is an interaction between the electrons of pi system and the adjacent sigma bonds of substituent groups. This we can show in this figure. In this, this is carbon-carbon, actually double bond shown, that is carbon single bond, and double bond is shown by this sidewise overlapping. These orbitals are pi orbitals, and these orbitals overlap with this sigma electrons. These electrons which form sigma bond are overlapping with this pi orbitals which form double bond. So hyperconjugation is a interaction between these pi orbitals and this sigma electrons of sigma orbital. So this interaction is called hyperconjugation. This we can explain with examples also further. So next is the applications of hyperconjugation. It is very important topic. In hyperconjugation, we show that it explains the stability of alkenes first. We have taken an example of alkene. It is propene, that is carbon, double bond carbon, then CH3. So these pi orbitals, as already explained in above example, these overlap with these sigma orbital which forms bond with hydrogen of carbon. So this is hyperconjugation. In this we now see that this is our system in which carbon-carbon double bond is present. So this adjacent group is CH3. CH3 has 3 hydrogens, 1, 2, 3. These 3 hydrogens, it means it can form bond in 3 different ways, or say once this hydrogen is involved in bonding, so its electrons moves towards carbon and it forms double bond, and the adjacent electrons moves to CH2 group. So this, it carries negative charge, and this hydrogen will have no bond with the carbon. It will be H positive. So similarly, the next hydrogen can also form bond with this. The other hydrogen also forms bonds like this. So now this remains with no bond, and these electrons move towards this double bond, and rest is same. So next is when third hydrogen can also form bond like this. So to the double bonded carbon atom, one methyl group was attached. This has 3 hydrogens, so 3 structures are possible, with one this, then with this, and third is this. So one alkyl group is attached, it has 3 hydrogens, so it can form 3 hyperconjugating structures. Similarly, in this, no alkyl group is present. Double bonded carbon atoms has only hydrogens attached to it. In this, one methyl group is present, so it can have 3 structures, hyperconjugating structures. In this, 2 methyl groups are attached, so it can have 6 hyperconjugating structures. In this, there are 2 alkyl groups, 1 alkyl groups here, that is, it can have 9 hyperconjugating structures, and in this 2 methyl groups are attached to this carbon atom and 2 are attached to other carbon atom, so it can have 12 hyperconjugating structures. So we can easily draw the hyperconjugating structures of all these examples. But what is important is, out of these alkenes, which is most stable? This stability can be explained on the basis of their number of hyperconjugating structures. Greater the number of hyperconjugating structures, greater is the stability. So this will be the most stable alkene, and this will be the least stable alkene. The order is shown. So the alkene with 12 structures is most stable, then with 9, then with 6, then with third, and then with no hyperconjugating structures. That is, larger the number of methyl groups attached to the carbon-carbon double bond, more the number of hyperconjugating structures, and greater is the stability of alkenes. And it can also explain the stability of carbocations. It can also explain the stability of carbocations. This we will do in next chapter, that is mechanism of organic reactions. So here is only the main concept of hyperconjugation. So hyperconjugation is very important. Its definition, its orbital diagram that we have done after definition, and then the applications. In applications, how it can explain the stabilities of alkenes or carbocations. This we will, of carbocations we will study further in next chapter. So next is now we have studied inductive effect and electromagnetic effect. Now we can easily distinguish between them. As we already know, in inductive effect, it is a permanent effect. Once an atom is attached along the end of the chain, the electrons move towards that permanently. And in electromagnetic effect, it is temporary. That is only in the presence of attacking reagent. And then is and then it is present in saturated compounds, that is in compounds where only single bonds are present, and this requires double or triple bonds, so it is present in unsaturated compounds. In this, no attacking reagent is required. In this, attacking reagent is required. And last is, it involves partial separation of charges, and in this, complete transfer of electrons takes place. When attacking reagent is attached, then complete electrons move towards that carbon atom or away from that. So inductive effect and electromagnetic effects are quite different, and so we have till now done inductive effect, electromagnetic effect and hyperconjugation, and we will start with resonance effect in the next lecture. Thank you.